Hi, so this is Srujan and this is my Practicum 2 submission for CS 5200 Database Management Systems course, which I've taken as a part of my Spring 2026 semester. So as per the requirements, I've built a complete expense data pipeline for Heraclitus Advisors PC, an international mining consulting firm. So as required, the pipeline has 5 stages. The stage 1 would be the synthetic data generation and followed by CSV loading into a normalized SQLite database, followed by a expense report creation in MongoDB Atlas, and then a star schema data mart in Ivan MySQL, and then an analytical report. So let me run all of these and explain my key design decisions. So here are the 5 programs that I have written. And so currently let's go through the stage 1, which is to generate the synthetic data. So in stage 1, we generate synthetic test data since the assignment does not provide any. This program creates 5 CSV files simulating credit card transaction downloads. Each transaction has 8 fields matching the assignment specifications: date, vendor description, amount which is negative for expenses and positive for credits. Each transaction has 8 fields matching the assignment specifications: date, vendor description, amount which is negative for expenses and positive for credits, credit card merchant, expense category and subcategory, currency and a billable flag. I'm generating data across 7 categories like travel, lodging and meals, with 25 subcategories, 6 currencies for the international nature of the firm, and 5 credit card merchants. So here we have successfully generated 523 transactions across 5 CSV files. Spanning from January 2024 through March 2026. It also creates reference data for 8 mining clients, 10 projects, 8 employees and 3 approvers, which will be used in the later stages. Now let's go through the stage 2 of the practicum. So here we have to convert CSV to SQLite database. So stage 2 is the intake agent. It reads all the CSV files from the intake folder and loads them into a normalized SQLite database. So I'm initializing this function. So if we can see here, there is a database, SQLite database created. So the schema is a 3NF form with 5 tables, categories and subcategories from a parent-child hierarchy. Credit card merchants and currencies are lookup tables. The transactions table has foreign keys to all 4 lookups. The 3 key design decisions here are: first, dates are converted from the CSV's month, date, year format to year, month, date and stored as character strings, not date objects. So this is as per the lesson which I've learned in this course, shows that our date objects don't map correctly to SQLite date columns. Secondly, I used name vectors as hash maps for foreign key lookups instead of querying the database for every row. This is much faster. And third, the transactions are batch inserted into as 100 rows at a time, wrapped in database transactions with db begin and db commit. So here in the output, if we can see, we have created 7 categories, 25 subcategories and 5 merchants and 6 currencies and all 523 transactions loaded. So the date query test confirms between function works correctly and 24 transactions are found in March 2025. Now let's go through the stage 3, which is the MongoDB expense reports. So the stage 3 simulates the expense reporting web app. It reads transactions from SQLite database and creates expense reports in MongoDB Atlas. So here I'm running this. So the key feature here is allocation splits. In a real expense system, an employee can charge a single expense across multiple clients at different percentages. For example, a $100 hotel stay might be 60% billed to one mining client and 40% to another. So each expense report document in MongoDB contains nested employee information and approver information. Line items with these allocation splits where percentages sum to 100%. So let me take you through the database. So here if we can see, so we have billed 70% to client called Freeport Macron and other 30% to Glencore. This is exactly the kind of nested document shaped data that MongoDB handles naturally, which for execution in a relational database would require multiple joint tables. So here we can see the 33 expense reports in the Heracles database. Now let's go through the stage 4, which is the MySQL star schema data mart. So this is the most complex part. It builds the analytical data mart. The program connects all three databases simultaneously, which is the SQLite database and even MySQL and MongoDB. So while it runs, the data mart uses a star schema designed as hybrid of the Kimball dimensional table approach and one big table approach as required by the assignment. The fact table has both foreign key lookups, foreign key columns linking to 6 dimension tables, that's the Kimball part, and denormalized name columns for direct querying without joins. That's one big table part. This means simple queries don't need any joins, while complex analytics can still leverage the dimension tables. So the fact table is partitioned by the year 2024, 25, 26 and a max partition for future data. After loading, I create 28 indexes across all tables for fast query performance. I used named vector hash maps for all lookups, project codes, client IDs, date IDs to avoid calling inside loops. All inserts are wrapped in transactions with dbbegin and dbcommit for concurrent access safety, and I use batch inserts of 200 rows at a time since Ivan does not support dbwrite table. So here we have populated all 6 dimension tables. So overall, 523 transactions expanded to 1025 fact rows because of the MongoDB allocation splits. $100 expense split 70-30 across 2 projects becomes 2 fact rows of 70 and 30 each. Partition shows 497 rows in 2024, 423 in 2025 and 105 in 2026. 28 indexes created and all 6 dimension tables are populated. So this is the final part of the practicum 2 where we have to generate an analytical report. Here I'm running all the chunks. And let's knit it to HTML. So the query 1 shows total expenses per category per year. Travel is the largest, over $36,000. Query 5 shows billable versus non-billable expenses per project. This is possible because of the allocation splits from MongoDB. And I would like to highlight this query 7 because it demonstrates the OLAP drill down operations. First yearly totals for travel, then quarterly breakdown for 2025, and the monthly detail for Q1 2025. This is the kind of analysis the fact table is designed for. Each level of detail is available without recomputation. So the query 10 is a year over year comparison using case when to pivot to the data. You can see that travel spending has increased from $15,000 in 2024 to $17,000 in 2025. So to summarize, the complete pipeline runs end to end in under 3 minutes. Data flows from CSV files to a normalized SQLite database to MongoDB for expense report allocation, to a MySQL star schema data mart with fact tables, and finally to an analytical report. The code uses packages which are learnt in the course like RSQLite, RMySQL, MongoLite and JSONLite. We have not used dplyr or no dbwrite table. All inserts use batch SQL statements. The fact table is partitioned, indexed and supports all required OLAP operations. Thank you.